Alright, hey everybody. This is Geometry, Chapter 2, Section 2, the first part of it. There's too much material to cover all at once, so we're going to break it up a little bit and do this section in 2 days. Yesterday we started by looking at 2.1, inductive and deductive logic, and now we're actually going to get it into action. We're going to find out how to start to use logical statements and how logical statements work together. Basically, our objective is this. You will be able to determine the truth values of negations, conjunctions, and disjunctions. You will represent conjunctions and disjunctions with Venn diagrams. So you're going to understand what all those words mean. 3 words: negation, conjunction, and disjunction. You're going to be able to determine when they're true, and you're going to be able to draw them with Venn diagrams. So it'll be relatively straightforward, but you have to take good notes today, because if you don't understand this, then you're not going to understand the whole rest of the chapter, or really most of geometry is proofs. And so if you don't grasp this, if you don't wrap your mind around this, you're going to be in big trouble. So just if you never pay as much attention as you do today again, it'll be the best time you could possibly spend. So get your mind in on this, take good notes on this, and make sure that you're paying very close attention. So some definitions. A statement. Any sentence which is either true or false is a statement. Now, if a statement cannot be said to be true or false, then it's not a mathematical statement. If a statement is true, if it's an opinion, if it doesn't make sense, those kind of things are not considered statements mathematically. But mathematically, I said the shape has 4 sides. That's either true or it's false. It either has 4 sides or it doesn't. So it is a statement with a truth value. That's what we say. Negation is just a statement with the opposite meaning. So to show you that here, the statement P is a rectangle is a quadrilateral. That is a truth value of true. It's true that a rectangle is a quadrilateral. But that symbol there, the tilde, is the not sign in math. So not P means a rectangle is not a quadrilateral, and that has a truth value of false. If the statement is true, then its negation will be false. If the statement is false, then its negation will be true. So the negation is just the opposite, and being the opposite will have opposite implications. So the statement that of P is true, so not P is false. We use that notation a lot, but it just means opposite. A couple more definitions. A compound statement is 2 statements joined by the word and or. Just as in a compound sentence, you have 2 independent clauses joined by a conjunction. In math, a compound statement is 2 statements that are put together by and or. So if I gave you the compound statement, the rectangle is a quadrilateral and it has 2 sides that are congruent. That's a compound statement. There's 2 parts there, and either one of them could be true, either one of them could be false. A conjunction is when 2 statements are joined by the word and. A conjunction is only true when both statements are true. So in math, and or take on slightly different meanings than in the regular world. That is to say that if I give you if I tell you I like pizza and ice cream, that means that I like pizza, that is true, and I like ice cream, that is true. So and is normal. And works the same way that it normally would in English. Or, as we're going to see, is a little different. If I say, do you want chocolate or vanilla, maybe you can't have both. But in math, you can have both. In math, it's either one. So and means both of them are true, or means at least one of them is true. But right now we care about this, conjunction. Con means together. Conjoined twins are attached. So a conjunction is two statements joined by the word and. A conjunction is only true when both statements are true. Here's a conjunction. You could write it P and Q. You could write it P with that little upside down symbol. That's the intersect symbol. That means and. I show that it kind of looks like the N in and, that symbol does, so I can help you remember it. Or, of course, conjunction, the N in conjunction. This Venn diagram is particularly useful. It tells me that this is true. If I called this, backtrack here. If this is P and this is Q, then P and Q is only true when P is Q and Q is true. It's only the overlap of P and Q. So P and not P, because wherever P is, not P is not, we'll have no solution. Give some example. Here's three statements. The figure is a triangle. The figure has two congruent sides. The figure has three acute angles. The figure is a triangle, two congruent sides, three acute angles. So P is a triangle. That is a truth value of true. Q, it has two congruent sides. That's also true. So you have marked then here that the two legs are equal. It has three acute angles. That is false. This is a right angle, and only these two are acute, so there are not three acute angles. So, if I gave you a statement, P and R, well, P is true, and R is false. So P and R is only true if they're both true. It's the overlap. It's the middle of the Venn diagram. So P and R is false because R is false. Okay. What about Q and not R? Q is true, and not R, R is false, so not R is true. True and true is true. Here, of course, true and false is false. And means they both must be true for it to be true. Not P and not R. So, sorry, do these on your own for just a second. So P and Q. Write on your paper if you think P and Q in this problem is true or false. So P and Q will only be true if P is true and Q is true, which in this case they are. It's true and true. Now what about not P and not R? Well, P is true, so not P is false. And R is false, so not R is true. Now these are not both true, so this compound statement is false. Now you understand then what I'm saying when I say this stuff is kind of complicated in that we don't use this kind of speaking in the outside world. This is just something you use for proofs, which is something you use in you only start using it in math when you get to geometry. And so it's something that is brand new to you. And because it's brand new to you, maybe it's something that you'll struggle with a little bit. So you've got to really work at it. But it's almost simple. And means that both the statements are true. Not means you flip it. So if P is true, not P is false. If Q is false, not Q is true. You just flip it. Now, the next thing we need to look at is disjunction. Now, P or Q. This means they do not have to overlap. It could be either one. So if this is P and this is Q, then the disjunction is the whole thing. P or Q, P, U, Q. This is the union symbol. So union is it's all brought together, but it's a disjunction. So if I gave you P with the union symbol, this means P or Q. This is what you need to remember. P with this, it's P and Q. This means not P. These are the three definition type things you need to be able to remember. So as you squeeze that together in your mind, let's try this. P, January is a fall month. Well, that's false, right? January is a winter month. So we can mark that false. January has 30 days. That's false. 30 days has September, April, June, and November. All the rest have 31. January 1st is the first day of the new year. That is true. So far, so good. False, false, true. So now, let's look at a list of compound statements and let's decide what's true and what's false. P is false. Q is false. R is true. So, P and Q. P is false and Q is false. So P and Q is false. P and Q is only true if P and Q are both true. Not P, since P is false, not P is true, and Q. Still, true and false is still false. R or P. Well, in this case, R is true, so R or P is true. R and not P. R is true, and not P is true. So this statement is true. Q or R. Well, Q is false, but it's or R, which is true. So the statement is true. Let me give you a little bit of time to jot that down. Okay. So this is kind of complicated. So let me go over it one more time with you. P and Q will only be true if P is Q and Q is true. Since P is false, they're not both true, so the entire statement is false. Not P and Q. Well, not P is not false, so it's true. And Q is false. Again, true and false is false. It's not true. If I say that, if I give you a true statement and a false statement, then I'm lying. The entire statement is false because part of it is false. R or P. In this case, when it's or, either one of them can be true, and that's fine. And so because R is true, the entire statement is true. If I told you I am either male or 108, well, only one of those has to be true for the entire statement to be true. If I say I'm a male and 108, they both must be true for either one to be true. R and not P. R is true, not false, not P. P is false, so not false is true. So true and true means the entire statement is true. Q or R. Again, Q is false, false or true. The entire statement is true. Now, I know this has only been about 15 minutes long, so you've still got the majority of class left, but this is something that's going to take you some practice to do. There's just no getting around it. These words are not familiar to you, and they're not going to get familiar until you work with them. And so the rest of the class period, I want you to work on this assignment, numbers 1 through 10, and numbers 17 through 22 on page 103, you're just going to do all those problems, it's 15 problems, and it's very, very important that you take the time to do them. You can consult the chapter, you can look at that. If you look up Justin Gatlin on YouTube, you should be able to find this video if you need to look at it again. So, good luck, work your very best on this. Like I said, this is kind of the foundation for everything that's to come in geometry, and I expect great things.